Hello. So today we're going to be looking at converting between degrees and radians. So we're going to do this by looking at taking a degree measurement and converting it to radians, and then converting a radian measurement back to degrees. So recall that the conversion from degrees to radians is that we know that for a circle, a complete rotation is 360 degrees. Well, we know that the distance around the circle, or the arc measurement around the circle, is 2 pi times whatever the radius is. Because we know that, we know then that 360 degrees could be related to that 2 pi. And so we call that relationship 2 pi radians. So 360 degrees equals 2 pi radians. Because of that, we have a ratio that we can simplify because we can divide both of those numbers by 2, and we end up with 180 degrees equals pi radians. Okay, great. Now that we know that, how do we use this conversion factor to convert between the two? Well, it'll be quite simple. So let's start off with just a very common uh, angle measurement. How about a right angle? Remember that a right angle is 90 degrees. So we're going to take 90 degrees, and I would like to convert 90 degrees into radians. Well, if we look back at our dimensional analysis, or how you generally do your conversion factors, I can say, well, I'm trying to get rid of degrees, so I'm going to put that down here at the bottom. And I'm converting to radians, so that's going to go up here at the top. And so what does that give me? Well, I get 90 divided by 180 times pi. And so what I end up getting then is 1/2 of whatever pi is, radians. Or generally speaking, this is written as pi over 2 radians. Okay? So we get pi over 2 radians for 90 degrees. So some of you may have seen this before because this is a very common radian measurement that's used, especially when we're looking at some trig functions that we will look at some later, but we won't do anything in regards to using trig functions with radians, but you may in other classes, so it's good to understand this conversion. But anyway, this is a common one used because pi over 2 represents 90 degrees. And a 90-degree angle is commonly used when building or when doing anything, honestly. So this comes up a lot. So this is a popular one to remember, that 90 degrees equals pi over 2. So a lot of times what people actually do is, in order to convert these, and they do these conversions quite quickly, and it's fascinating to see, but what they do is they say, how much is this out of 180? Because I know pi is 180. For instance, if I said how many radians is 30 degrees, people would say, well, 30 is just 180 divided by 60, or divided by 6, so it's going to be pi over 6, and they're done. And it's like, yes, that's correct, and that's a quick way to do that. But what's actually happening is we're just saying 90 out of 180 is what fraction, and multiplying times pi. Now, some of you are probably going to say, well, can I just multiply times 3.14? Or some of you may even say, can I multiply times 22 over 7 because that's close to pi? The answer is yes, and the answer is yes. So to both of those. Any approximation of pi will probably get you very close enough if you want to have this as decimals, a decimal approximation, and you'll be fine with that. However, it's not necessary in most cases. Most cases you can leave it as pi over 2 or whatever pi, and there are tools that you can use actually to measure that a certain number of pi, because pi is going to be that entire straight angle. So if you have that tool, you're saying, well, what fraction of this semicircle am I going? And then that will tell you how many pi's you have, or what fraction of pi radians you're doing. And so they have tools to measure that. So that's not necessary to say, oh, I'm just going to multiply by whatever the approximation of pi is that I want to use. If you're told to do that at work or in a school setting, do it. Any other time, it's not necessary. So, okay, that's how you convert from degrees to radians. Well, let's go the other direction. Actually, let's look at one more example. So what if I gave you something a little more abstract, say something that didn't seem as easy. Well, let's say I gave you 27.2 degrees, and I need to convert that. Well, 27.2 degrees, we're still going to do the same conversion factor. So we still have pi radians we're multiplying by, and we still have 180 degrees we're dividing by. And so when I do that, though, I end up with 27.2 divided by 180 will give me 0.151 repeating pi radians. Now I can rewrite this a little differently if I want to, or I can also change it to a fraction if I want to. It's up to you and up to the situation that you're doing. In this case, well, personally speaking, I like to leave things as a fraction. But in this instance, if I'm using this as an actual measurement, I think the 0.151 would be enough. It also depends on significant figures. In this case, I'm given 3 significant figures, so maybe I would just leave this as 0.51 pi and call it done. Okay. All right. So again, that is converting from degrees to radians. So to convert from degrees to radians, remember you multiply times pi and you divide by 180 because pi will be 180 degrees. Okay. Well, let's look at going the other direction. So going from radians to degrees. So going from radians to degrees, let's do 57.3 radians. Okay, and we're going to convert that into degrees. So again, we're converting from radians to degrees. So in the numerator up top here, I'm going to have 180 degrees, and down here at the bottom in the denominator, I'm going to divide by pi radians. Okay. And so when I do that, I'm going to take the 57.3 and multiply it times 180. And I'm going to get 10,314 divided by pi degrees. Now, when I'm looking at my protractor or my compass and I'm measuring degrees and I'm trying to see how many degrees that is, I'm probably not going to see something where I can have a tool that's going to have it divided by pi every time. Not when I'm looking at it in terms of degrees. So what can I do? In this instance, it'd probably be a smart idea to divide by that. So I'm going to divide by pi, or the approximation that my calculator has for that. And when I do so, I actually end up with 3,283.04 or 0.05 degrees. That is a lot of degrees, isn't it? Yeah. In order to get to 3,000, it had to go around at least 9 times and then some more. So this angle would actually have another reference angle that you could compare it to. That would be less than 360. If you wanted to find that out, you could just find out what it would be for the 10 and subtract it to. Okay, so that is how you convert from radians to degrees. Let's look at another example. I'll actually write it underneath it. So more commonly what you'll see is a fraction version of the radians, and you need to convert it with a pi in it. You need to convert it back into degrees. So for example, I'll do pi over 7 radians. And so in this instance, what I like to do is I like to take that fractional bar and extend it out, because remember I'm converting to degrees, so the 180 is going to go up here and the pi is going to go down here. And so the reason I draw that fractional bar out is because this way I can clearly see that, hey, not only do the radians cancel, but my pi cancels. And so pi over 7 radians actually is going to just be whatever 180 is divided by 7. And so when I do 180 divided by 7, I end up with 25.7125 degrees, roughly around there. Okay, cool. So in these regards, you may round due to significant figures. In this case, we had 3 here. In this case, we have a symbol that represents a very, very long number. So your significant figures that are given, honestly, we don't have a significant figure that's automatically given. Sometimes people will say stuff like this is, say that, well, this is based off whatever you use for pi. So if you use 3.14, it would be 3 significant figures that you're using. But in this instance, really, it's just 1 because we're just dividing by the 7, and the 7 has 1, and that's the least number. So, but most time in these cases, you're not asked for significant figures. You're asked to give the best approximation you can because you want that angle to be as close as you possibly can. Now, what really gets fun is when you do this conversion and you are then asked to put it in degrees, minutes, seconds. But that's okay. We cover converting between decimal degrees and degrees, minutes, seconds in another video. So, how do you convert from degrees to radians and radians to degrees? It's very important to remember the conversion factor. 180 degrees equals pi radians. So if you're going from degrees to radians, we'll divide by 180 and multiply by pi. Sometimes people think just stick it on the end, which is fine too. If we're going from radians to degrees, we will divide by pi and multiply times 180. All right, so that's converting between degrees and radians, and I will see you soon.